This diagram illustrates a common, expensive hurdle in cloud networking, exposing every Kubernetes service to the internet by giving each one its own dedicated load balancer. It's like building a private airport for every single passenger. You pay for redundant infrastructure, and your cloud bill will climb with every new service you deploy. A more efficient approach places a single unified gateway at the edge of your cluster. This is the Ingress Controller. Instead of a dozen load balancers, you provision one. That controller receives all external traffic and distributes it to your internal services based on a set of rules you define. To manage this, you need two distinct components. First, the Ingress Controller itself, which is the active proxy, like NGINX, that physically routes network packets. Second, the Ingress rules. These are the declarative YAML instructions telling that controller exactly where to send a specific request. Consolidating external access under one controller addresses the cost sprawl and the complexity of managing multiple public IP addresses. You have one front door and one set of rules governing every entry point. Before writing a single routing rule, you must have an Ingress controller installed in your cluster, typically via Helm. While the Kubernetes API recognizes Ingress objects by default, they are just empty files until a controller executes them. The controller directs traffic using host-based routing, reading requested domains like api.example.com to map to a backend service. You can also route by URL path. Exact matches the path perfectly, while prefix acts as a wildcard, routing all /API requests to your backend. This is a frequent point of failure for new setups. The cluster will accept your Ingress YAML without errors, but if the controller pod isn't actively running or watching your specific Ingress class, that traffic will simply disappear. These rules decouple your public domain names from the internal cluster structure. Because the mapping happens at the gateway, you can rename internal services or move them between namespaces without needing to change your public-facing URLs. Routing traffic is only the first step. That traffic must be encrypted. Historically, serving HTTPS meant manually generating TLS certificates and rotating them by hand. It was a manual process that was easy to break and hard to scale. Cert-manager replaces manual uploads by running as a background agent. It watches Ingress resources, validates your domain with Let's Encrypt, and generates the TLS secret. To provide certificates, define a single namespace issuer or a cluster issuer to serve your entire cluster. When you start, you should point your configuration to the Let's Encrypt staging environment. The production environment has strict rate limits. If your configuration is wrong and your cluster repeatedly requests a certificate, you will be temporarily blocked. Let's try a quick exercise. Pause the video and write the YAML to route admin.example.com to a service named admin.svc on port 80. Make sure to include the annotation to request a certificate from a cluster issuer named Let's Encrypt prod. Automating TLS at the ingress layer is a core requirement for modern security. It removes the risk of human error, ensuring your services stay reachable with valid, trusted certificates. Here is the correct configuration. The host rule maps to our admin SVC, and the cert-manager.io/cluster issuer annotation tells the cluster to secure this route using our production issuer. When you update that annotation from staging to production, cert-manager automatically completes the final challenge. The result is a fully trusted, browser-recognized certificate for your domain. Annotations allow you to define more specific behaviors for your traffic. For example, adding a limit RPS annotation instructs the controller to cap requests per second. This ensures that a sudden surge of traffic is throttled at the gateway before it can overwhelm your backend pods. This architecture rests on 4 pillars. The controller is your gateway. The rules provide your routing logic. Cert-manager handles security automation, and annotations extend the system's functionality. Combining Ingress with cert-manager automates the lifecycle of your public endpoints. The cluster manages routing logic and certificate rotation, maintaining secure access as your underlying services evolve.